In our previous session, we had seen takeoff performance. Let us see landing performance in this session. Consider an aeroplane during landing. After the aeroplane has touched the ground, the force diagram during the ground roll is exactly the same as given in this picture, and the instantaneous acceleration is negative. However, we assume that in order to minimize the distance required to come to a complete stop, the pilot has decreased the thrust to 0 at touchdown. And therefore, the equation of motion for landing ground roll is obtained as thrust is equals to 0. Assume an average constant value for d plus nu r w minus L that effectively yields the correct ground roll distance at landing. We assume that d plus u r nu r w minus L average is equals to the instantaneous value evaluated at 0.7 vt, that is velocity at touchdown. Therefore, F is equals to T minus D minus R, which is equals to T minus D minus nu R W minus L is equals to m dv by dt. Therefore, the equation of motion for landing becomes minus D minus nu R W minus L is equals to m dv by dt. To maintain factor of safety, Vt is equals to 1.3 V stall, which is equals to 1.3 root over 2W divided by rho infinity SCL max. Combining these two equations, we get landing ground roll distance is equals to 1.69 W square divided by d rho infinity SCL max into d plus nu R W minus L into 0.7 Vt. During landing roll, the pilot is applying brakes. Hence, the coefficient of rolling friction is that during braking, that is approximately nu r is equals to 0.4 for paved surface. Modern jet transport utilize thrust reversal during landing ground roll. Thrust reversal is created by air from the jet engine and blowing it in the upstream direction, opposite to the usual downstream direction when normal thrust is produced. As a result, with thrust reversal, the thrust vector is reversed and points in the drag direction, thus aiding the deceleration that shortens the ground roll. To shorten the ground roll is to decrease the lift to near zero, hence impose the full weight of the aeroplane between the tires and the ground and increase the resistant force due to friction. The lift on an aeroplane wing can be destroyed by spoilers, which are simply long narrow surface along the span of the wing deflected directly into the flow, thus causing massive flow separation and a striking decrease in lift. The total landing distance as defined in FAR is the sum of the ground roll distance and the distance measured along the ground to achieve touchdown in a gliding from a 15-meter height. Let us see landing performance through an example. The empty weight of Cj is 12,352 lb. Velocity Vt is equals to 1.3 V stall, which is equal to 148.6 feet per second. Hence, substituting it in 0.7 Vt, we get 104 feet per second. The average force should be evaluated at velocity of 104 feet per second. As we know the drag formula, we can substitute the parameters and we get the drag is equals to 89.9 lb. The landing distance with L is equals to 0, we get, substituting it in the formula of 1.69 W square divided by G rho infinity SCL max D plus nu R W into 0.7 Vt, we get landing distance is equals to 842 feet. I hope you would have understood landing performance. Let us move on to turning flight in the next session. Thank you.